See, we've birthed some particles. There they are, they've been birthed and they're flying outwards. Pretty typical flow. And you can see that at this point we have a send out test, which we'll come to later in this DVD. That sends out all our particles and they get sent to the second event, where you can see in the second event we've actually got an age test based on the particle age. Now in this case we're testing for a value of 20, and it's pretty much bang on 20. So when every particle reaches 20, it then goes on to the next stage. When it goes on to the next stage, you can see the particles spawn new particles, and this causes a little mini explosion. And once they've done that, the exploded particles and the original particles are tested for a random value of between 5 and 25. When they reach that, they're sent on to the next event where they're killed off by the delete operator. So if we scrub through the timeline, you can see on frame 20 all the particles explode. Now the reason why they're not actually all exploding together is they're not actually all born on the first frame, and that's just to illustrate that there is actually a range here. So if I put this to 0, they all get birthed on the first frame, they fly outwards, and exactly on frame 20 they all pop. They're all sent on to the next event. So you can see they spawn new particles, they fly onwards, and after a random age they are deleted in this last event. So if I go back to here and I change the emission stop to 30, there'll be a much wider range in the actual age in our particles, and you'll see that they start flying at a different time, and you can see they're actually being sent on to the next event where they spawn at different times as well. So you have some particles which have gone on to the next event and spawned, and you can see that there are some particles which are still in the first event. So there they go. If I change this to 0 again, and I base the age test on the event age of the particles, you'll see the age test is set to 20, which is actually 20 frames after the particle enters this event here. So you'll see when it reaches 20, it pretty much does the same, because they're all entering this event at the same time, which is basically straight away. So you have the choice really of choosing event age when the particles actually enter the event, and after that point you can actually use a timer to decide when they get sent on to the next event, or you can use particle age, which is generally the most useful option as it's actually based on each particle. And then you have the absolute age, and that's actually based exactly on a certain frame. So just to demonstrate that, I'll move this down here, quickly turn on the display of the depot. I'll get an age test, which I'll just put here. I'll actually turn off the send out, and I'll drag the wire over here to put it on the other side so we can actually see it a bit more clearly. I'll pop this here, get rid of this wire. I'll turn off the display of the depot again. We don't really need it. And now what I'll do is I'll set this age test to be an absolute age, and that absolute age is going to be, I'll get rid of subframe sampling, put the variation to 0, and I'll set the actual age to 10. There we go. So now if I use an age test at an absolute age and we set it to 15, you would expect the particles to be sent from this event into this event on frame 10, and then on frame 15 you would expect them to actually explode. So let's see if we get that. So there we go, they go into the next event. Actually what I'll do is I'll get rid of this display operator just so that our particles display the same, because they are actually the same. And I'll copy that display operator to there, so it actually doesn't change appearance when it goes from event to event. So the particles fly outwards, and then on frame 15 you can see they pop. Now if I change this value to particle age, that's based on the age of each particle. They're all born at the same time, so there should actually be no difference really between those two things. So there out goes the particles, they go into the next event, and on frame 15 they all pop. There's no difference there in the end result. Now if I go to this test here and base the test on the event age, the particles will only pop when they've been in this event for 15 frames or more. So you'll actually have quite a different result now. They go into the next event at this point. When they reach frame 10 they get sent to the next event, and now instead of popping on frame 15 they will now pop on frame 25. There you go. So that's it. That's the age test. As you can see, it's relatively simple actually what it does. It's very, very useful. If you want any sort of time-based measurement or test for your particles, then the age test is obviously the test for you. Okay, now that we've had a look at the age test, let's move on to the collision test.